What is going on, guys? Welcome back to another episode of the Oil and Gas Startups Podcast. I'm here with Britton from Texas Integrity Acid Solutions.
Yep.
Wait, what's the acronym for that? Texas
TIAS.
TIAS.
Yeah, thanks in advance.
Yeah. Tell me about you guys. What are you guys working on?
So we kind of started out as just doing a production acidizing deal on the production side. There's just a little hole there where I'm from, College Station area. It's a lot of Austin chalk stuff. Had just a hole there that needed to be filled with some good quality acidizing on the production side, cleaning up some calcium carbonate and some things like that. Production enhancement type jobs. And so that started in mid 22. By November of 22, gotten a call from one of the local operators that frac had kind of dropped the ball, didn't bring acid for the frac job. And they asked, like, hey, could you take care of this for us? It's like, yeah, man. I mean, there's only two of us, but yeah, sure. We'll do what we can. So we kind of slapped together a manifold essentially so we can roll the tanks and get consistency in the tanks on the frac. And got into some problems there. Fracking ended up putting a bunch of FR back into the acid tanks, and it threw their hydrometers off. And so they kind of called me out there to location one day and were like, hey, we're showing 8%. And I'm like, I know that tank is at least 15.5 because I'm the one that ran the numbers. I delivered the loads. Like, I know what it is. So long story short, end up having him pull a sample. He pulls his hydrometer out and I look at it and I can see it just kind of running off the hydrometer. So I reach over there and pick it up, smell it. I'm like, dude, that's FR. I said, y'all have FR in this tank. Like y'all have overpumped the last 4 stages because y'all had pushed FR into it. Ended up missing one of my daughter's deals. So I kind of got back to the yard and talked to Greg, one of my partners in this deal. Told him, I was like, dude, this is stupid. Like, it's 2022. Like, we can eliminate all of this as a variable. Like, there's no reason somebody should be having to stand there with a strap stick, a face shield, and a respirator trying to read inches off of a strap stick that's never accurate anyway. So that's kind of how that started, dude. Got a case of beer, wiped the job board off that we had, and started writing out schematics for how to do this automated. And that's where it started.
Dude, that's awesome. Okay, so for those who are listening, and most people are probably going to be familiar, but for those who don't understand, what is the point of acid? What are the use cases? Like, why are we using it?
So the historical portion of the acid stage, which they've been pumping acid in oil and gas wells since like the 40s, they are using the acid as an initial breakover so they can start catching rate. Now, the problem that we've always had is we dictate what our acid percentage is based on like a lab test, so a bench test. Mm-hmm. Well, that's done under absolute perfect conditions. And there's nothing in the oil field that's perfect. So it started dawning on me, with acid being heavier than water, if those tanks are not constantly agitated, what are you really pumping down hole? So let's just say, okay, we go out there, we blow acid off into a tank. We think we brought that tank to 15% by numbers, but how long does that sit before it starts to phase out? So while you're asking,
does it separate?
Yeah. So okay. So the acid will fall out of solution to where you'll have, let's 28% on the bottom and 4% on the top. So talking to some of the engineers, we could see on their historical data how the initial stages would have a drastic breakover. And then as they pulled that tank down, it would get less and less and less and less and less. So starting to talk to these engineers, it's like, man, I think I can solve this. Like, this is a problem that every operator has that pumps acid. It's just, how do we implement this into the field and what benefits do we get out of it? And that's kind of where we're at now, is we're starting to get all of the data back from the jobs that we've been doing. And everybody that has used the system so far, not just from a safety aspect of it, because there are no more acid vapors on location. Like I've been on fracs before at RSI that we had to shut down entire frac jobs because the wind was blowing the wrong direction. Line boss couldn't get in there to do anything. So we had to shut the whole frac down until the winds would change or they get done blowing acid off. It's like, this is dumb. Like we can fix this. This is 2022, 2023.
So are you guys actually making the acid itself, or do you guys have a proprietary process of whenever the acid is sitting there, it's not separating and therefore makes the process, I'm assuming. more
Yeah,
efficient.
so I designed and developed a process flow patent that will automatically pull raw hydrochloric acid and water on the fly, blend to the correct requested concentration and volumes, and boost that to frac for their acid stage. And
Okay.
it doesn't matter whether it's 5%, 7.5, 10, whatever number that is, up to about 20 barrels a minute.
And the primary use case is acidizing during frac.
Yes.
Okay.
Yeah.
Do you guys do anything in the production space or just frac?
No, so the system would work on large scale production acidizing jobs,
Okay.
but unless you're over 25, 30,000 gallons, it's easier to run that out of a transport because there's so much logistics involved. But once you get to those types of volumes, so most fracs, they're running anywhere between 1,000 and 2,500 gallons per stage through the course of that well. So it may be 250, 300,000 gallons of blended product. And being able to keep these products, as far as the acid is concerned, in its raw form, there's no waste. So as opposed to them having to pump heavy on the tail end just to pull that tank low enough so they can move it, we're able to actually move that product from that pad to the next pad. So there is no waste essentially left over.
So talk to me, you touched on it a little bit, but talk to me about when you do this wrong, like in the example you said where they were kind of overpressuring it, expand upon kind of the problem there.
So the issue when you're pumping too heavy of an acid concentration down hole, the acid's not treated for that concentration. Now that could cause extra emulsion issues down hole. You could start eating your casing up. I mean, there's tens of problems that could happen out of that. Exactly what all of them are, I'm not a chemist. I don't know. I'm a field guy that just kind of noticed, hey, this is a problem that everybody has, and I think I've got a solution to fix it. So that's kind of where we're at. I'm only as good as the people I rely on. You know what I'm saying?
So give me a little background on kind of your career. How'd you get to this point? I know you told me kind of immediately how you came up with the idea, but let's go back a little bit further.
Yeah, so I started in oil and gas. I was actually working for Volvo Construction Equipment.
Okay.
They wanted to open up an oil and gas division in that Bryant College Station area.
It was crazy. We were talking about we went to high school together.
Yeah.
And never really crossed each other's paths. Knew a lot of the same people, but I'd never had any exposure to oil and gas until I was like 19 years old, I think, 18 or 19. And a buddy of mine all of a sudden got a job as a mud logger and then had a new truck and had a fucking Sea-Doo and had like a and I was like, I need to work in oil and gas.
Yeah, oil and gas is where it's at.
Yeah.
Yeah, so my family's not oil and gas background. They're all bankers and real estate guys and women. But Volvo kind of opened the doors. So I started out actually as the mining side. So like big Hitachi 1900 EXs, like massive equipment, because Bremont has a big mine there. There's one in Franklin, one over in Caussy, and that was my area. Well, oil and gas was kind of tied into that mining area because that's what the mining place would do. They'd lease out some of that land to the oil and gas. And I just happened to be driving through there one day and saw a bunch of big bulldozers. They were laying a pipeline. And I was like, hey, this could be a potential new customer. Well, Volvo had never done the oil and gas before. So it was a completely different type of billing. Like they looked at it like if you were using that piece of equipment for 8 hours, it's a day rate. Well, oil and gas is 24/7 anyway. So we kind of had to figure out the best way to start billing for that. So finally did. Ended up kind of pulling all this in, joined one of the local API chapters. Through that, I met some guys from Bronco at that point in time, and they do like hydraulic chokes and flow back and things like that, which that was a whole new world to me. Enjoyed that, but through that, I was around my first pump truck, like actual pump truck. It was a double, and Bronco was building them in-house at the time. And it's like a 2,000 horsepower double pump. And I was like, oh, this thing's badass. Like, I'm in love. Like, it's huge. It's loud. Like, I have no idea what it does, but this is what I want to do.
Yeah.
So spent some time there at Bronco and learned a lot. And my district manager at the time, his dad was the general manager of Bronco out of Elk City. So they kind of were able to fast track me on, hey, you know, we need you to get in the field, understand how everything works. And then it's a lot easier to sell a product, obviously, if you know what that product does. And that's one thing in oil and gas that I can say, you know, better than most industries is the people that are selling for it. You can tell the ones that really know what they're talking about and the ones that don't.
Mm-hmm.
And that was something
you can sniff it out real quick.
Yeah. Yeah. I mean, it only takes 4 or 5 minutes there and you know whether or not somebody knows what they're talking about or they don't. Got through Bronco. This would have been in late 2013. Kind of got crossways with one of my customers at Bronco. So they ended up terminating me off of that deal. So I was kind of, you know, aimlessly walking around like, oh shit, now what do I do? You know, there was a frac company that was local to Bryan College Station area called RSI.
Okay.
And I walked over there and sat down in the office with one of the owners and got to talking to him. And he was like, man, I'll give you a chance. Like, you know, horsepower, you see savvies, how that all goes together. Didn't know anything about frac. This was in 2014, you know, right when frac is booming. So I start learning frac, getting all of that under my belt, understanding acidizing, start putting procedures together for whether that's frac or it's remediation work on the acid stages, and actually sitting down with engineers and getting a wellbore diagram with all the perforations on it and bottom hole temperatures and coming up with volumes for acid and diverting for acid and what that might look like, putting it all down on paper and then taking that out to the field and implementing it and watching those pressure charts. Like, okay, I think within the next 5 barrels, acid will be on these perfs. This is kind of what I'm guessing 250, 300 pound pressure drops. And then all of a sudden you get a 600 pound pressure drop. It's like, okay, we're on the right track. And something about that just really got my gears turning. Like, okay, how much larger on a scale can we make this and still increase production, you know, as a team? And I think it was a camaraderie as a team that made it more fun. And then from there, we sold RSI to Keen Group, which is now Next Tier at the time. They offered me a similar position at Keen that I had at RSI, but they wanted me out in West Texas. And there was no way that I was going to move my family to West Texas. That was not an option. And I don't really have the mentality of being able to work for a large company like that. I'm not as politically correct as what you really need to be to excel in that type of environment.
You and I both.
Yeah. So kind of went through a couple of phases there. Got some partners on another deal right after RSI sold. That would have been mid 2018. Legality reasons can't really go into, didn't get along with those partners. There were some things that I didn't like. So I actually got reached out by a company that I was leasing some frac pumps from called WebTex. And the owner of that company had some unfortunate things happen, and his sister had ended up taking over, and she doesn't come from an oil and gas background. So she was like, hey, would you mind coming out and selling this, you know, these frac pumps, or leasing these frac pumps for us to other people? And I was like, well, I mean, these are guys that I've competed with for the last 10 years. Like, I don't know if that's a good move for you, because I don't know if they'll even talk to me, essentially, because we've literally been bidding against each other for 10 years. But I took it, and that was a great deal. I learned a lot on the manufacturing side, like how the actual pumps go from raw parts to being put together to make a frac pump, which was something I was never a part of because I come from the service company side. So anyway, got to meet a lot of really cool people on that. And it's kind of where it's brought me to where I'm at today. Just knowing, okay, I can call this vendor for this style. I can call this vendor to have it all put together. I know these electronics guys, just putting all of that together. So I almost feel like it was almost fate. Like as you go through it and look, it's like, man, I don't know if I'm just out here on blind faith or if this is all happening for a reason or what. But that's kind of where we're at now.
What are you most excited about?
Changing how we look at the acid stage. So the biggest problem I always had is now that we're so big into the data analytics side of it, we can do frac models, but those models are only as good as the information that we put into them. So if we're saying, okay, our acid stage is 15%, and you're really pumping 28%. How is that model accurate at all? You can't.
Yeah.
It can't be. And, you know, I've talked to several engineers, like even before I had this thing built, like I was sending out thousands of emails, just cold call emails. And as it started, like I'd send 300, I might get 1 or 2 responses.
What were you emailing? Was like, hey, is this a shit idea? Would you buy this?
Yeah,
like, what's your
essentially,
feedback?
hey, this is what I'm building. This is the benefits that I think are going to be given as far as this system is concerned. What is your feedback? How do you feel about it as far as its implementation? Like, is this something worthwhile, or literally am I on the wrong track?
And did you start that before you actually technically started building?
No, we were already
we were already
under R&D, dude. So we started doing these drawings in December of 22. I was testing the unit November of 23. And I mean, that's what I'm telling you. It was blind faith. Like, I don't know if this thing's going to work. Nobody's done it. And that part was what really scared me. Like, cause when you've got a Halliburton, Schlumberger, like Liberties, you've got all these really big companies that them spending, a couple $1 million on R&D is no big deal. Like, they don't even notice. But me, it's like, oh, like we rolling the dice.
Yeah.
And let's see if it works.
So how is data analytics kind of changing the game in the asset space?
So because we know for a fact that this volume, let's just say it's 2,000 gallons of 10%. 10%, we know from a bench test in perfect conditions, we'll get X amount of dissolution rate, whether that's limestone or shale or whatever that is. So we have a baseline, but we don't know exactly what that means down hole because it's not clean like it is on surface.
Yep.
So giving us the ability to change that 10% to, let's say 8.25 or 7.5, or maybe it's all wrong. Maybe really what we need to be doing is 5% or 6.5. We never had the ability to do that. So this gives us that ability to say, okay, we know now 2,000 gallons of 5% downhole in a real world situation will give us X amount of breakover. Not that every single well bore is the exact same, because they're not. But they're close enough related that we can say, okay, that 5% does, let's just say it's a 250 pound breakover. Okay, we jump to 7.5% and we get a 600 pound breakover. Jump to 10 and now we're at 1,500 to 2,000. Okay, so where's that happy medium where we can actually start grabbing rate to start putting dirt in the ground? We're figuring it out. And that's what really excites me.
Is nobody else in the asset space kind of using data analytics, or is this kind of becoming more of the...
No, there's nobody out there that does it. I mean, that was the other side, is like, maybe we're not on to something if nobody else is doing this, and I've gotten mixed feedback, like from engineers, like really good friends of mine that I've known forever, and I'm pitching this idea to them before, while I'm still in design phase. And, a couple of them are like, well, I mean, we get billed for the right amount. We know that it's not consistent and we're not getting the consistent that you're saying, but we're getting billed for the right amount. So, who cares? I'm like, okay, well, that's not the engineer that I'm going to be able to target that matter. But the Exxons, the Oxys, those guys that really dive deep into their analytics and their data to want to come up with a better frac program, those are the guys that care about that type of stuff on top of the safety.
I imagine if I was starting an E&P, I would want to, because you're mentioning this is a broader kind of issue. And I think that we've seen this with digital wildcatters, is that a lot of the people who spend the time to either listen to the show or come to the events, like I would kind of categorize them as a little bit maybe of overachievers, right? They're spending extracurricular time that's going to hopefully advance their career, right?
Yeah.
Then you've got everybody else who's like, they're not social, they're not consuming stuff. Maybe they're still educating themselves, but they're not like really putting in that extra time, going that extra mile. I would want to build a company that incentivized everybody at that company to perform at the smallest of just having attention to detail to the littlest things and making sure that they are incentivized to always do that thing.
Yeah. Yeah.
You know?
Well, and I mean, just to expand your knowledge base.
Yeah.
I mean, just that part alone. I'll tell you, I've thought.
I just
more
hate that
about
whole "oh, it's good enough" mentality.
Yeah, I do
fucking
too.
I loathe that.
And granted, one of them, the one that was the worst on it, he's one of my best friends. Like, I talk to the dude all the time. So you've also got that. You know,
He's probably gonna
too.
listen. You can tell him to go fuck himself.
Oh yeah, no, 100%. You know, what's up, Will? But the reality is he does get it. When we actually get into a serious conversation about it, he's like, yes, I mean, I do see what you're doing, and yes, that does make sense for the companies that really want to implement that type of system. But also a lot of that too is a new technology. And I would be the same way if I were an engineer looking at a startup essentially and saying, okay, well, you did this, but why has Halliburton not done this? Or why has ProFrac or Liberty or whoever, you know, that is Schlumberger, since we've been doing this since the 40s? And the only thing I can really come up with as why that system's never been implemented into the field, because the technology's been there, is only because it's honest. It does not lie. So, and I'd be lying if I said I wasn't guilty of it at RSI. You know, oopsies happen in the field.
Mm-hmm.
And, you know, you pull a tank down a little bit more than what you should have. Well, we'll just cut the water on and bring that tank back up to the right level, not really add the acid into it, and nobody's the wiser. That happens all the time. So I haven't figured out yet if it's a lack of communication between the field and the engineers themselves, or if it's just a lack of understanding what the importance is of that acid stage. I'll say from all the pump schedules I've ever looked at, the majority of them are almost cookie cutter as far as the acid is concerned. And it's usually either 7.5% or it's 5%, or 7.5% or it's 15%, depending on what formation you're in and what area. And I think that's not because anybody's ever tried to do something different. Because of course, if you screen a well out, you know, now you're in trouble for sure. But there's no other way to learn. Like, we have to know, not to mention the cost savings that you have on that. So you've been pumping 15%, but if that well only needs 10, you've been over pumping by 5% each stage. You know, you extrapolate that over the course of a year, and you're talking about $500,000, $600,000, $700,000 in added costs that did not need to be there to the AFE. And it was just kind of trying to put all of these things together and say, hey, here's a safer solution that is accurate, it's consistently better, and you don't have waste. So we don't have to have as many trucks coming in or out of locations. So that's less hazards, less accidents. I mean, it's all the way around a better system, I would think. You know,
so when you're actually building and like designing this system, like walk me through that process. I'm assuming you probably never built or designed anything before in your life. You're like, all right, well, I just got to figure it out. So are you just, I don't know, walk me through it. I mean, is it, how'd you go about actually, like, are you manufacturing stuff? Are you just finding pieces and kind of cobbling them together? Like, walk me through that.
Yeah. So I have enough experience in the field, and I've got some really good guys that work for me or with me, I guess is probably a better way to put that. And we all have our strong points. Like, I know that I'm not the most mechanically inclined guy, but I have that guy that is the most mechanically inclined guy. So we all get together and it's like, all right, man, I'm not going to come up with the best idea. You're not going to come up with the best idea. But if we take pieces of everybody's idea, and that's essentially what the whiteboard was. I mean, we had multiple minds sitting around saying, okay, we need to be able to pump it at this rate in order to keep frac from cavitating. Okay, so we now know what our horsepower size is that we need to have. We know how much flow we need to get. We need to figure out how we can automate the valves to be able to dose that in the correct values. So pharmaceuticals, mining applications, food, nuclear power plants, all of these industries use hydrochloric acid. They're the largest users of hydrochloric acid, and they all have to be super accurate. Why is it in the oil field that, you know, essentially 3 to 5% on frac is an acceptable margin of error? that seems kind of large, you know?
Can you imagine if there's like a 3 to 5% margin of error on like the fuel supplied to like the jets you're flying around?
It's like, yeah, seriously. Like
Have another Boeing case on your hands.
Yeah, I remember at one point in time, we were saying, okay, a 10% margin of error is good. And I'm thinking like, oh, that's wonderful. So fast forward to testing phase, right? So we get to testing phase and we get this deal rolling. And we came out of the gates at a 2% to 3% off. And I was running around high-fiving everybody like super pumped. I get over to the programmer, and he's the guy from Germany. And, I'm trying to give him high fives and hugs, and he's just looking at me like, what are you doing? I was like, dude, we're in it. Like, this is going to work. He's like, oh, no. He said, we get it better. Like, what do you mean we get it better? I'll be damned, dude. By the end of that 3-day period, we had that thing down to a 0.25 margin of error at, 420 to 480 gallons a minute. I mean, which is huge.
So do you have like this, is it I don't know, is it some sort of like, is it a compressor of some sort type, or is it like,
so it's like
what's actually pushing the volume?
So it's centrifugal pumps designed for the application that they're in.
Okay.
The problem is those types of volumes, a lot of those pieces are having to be custom made to withstand that raw hydrochloric continuous volume at that rate and still be accurate. I'll tell you, there's a whole lot of metals that I've never even heard of before that I found out through the hard way by trying, Hasta alloys and titaniums and all this other nonsense until we finally found one that, hey, this is accurate. This does work. We can do this to where we're not having to replace it every, couple of days, essentially. But on the flip side of that too, it makes that learning curve further and further out because, okay, well, we need to try this. And a lot of it's trial and error. Nobody's ever done it. And maybe this is why, because it's a lot to try and figure out as you're going. Got a really good customer right now that savvies what we're trying to do. They believe in the product as far as they want to be able to make the best pump schedules that they can to make the best wells that they can. So they've kind of allowed us to have a backup plan in case we do have some type of issue.
Yeah.
We have a backup plan to keep them up and running. But so far, we've had very little issues, but it's been a long road from, essentially testing to getting into.
What was like the single biggest challenge, or if you've got a story of just something that totally just went sideways?
The single biggest challenge is because the unit is mobile and most of the other sectors that need accuracy or want accuracy
are not mobile.
They're not mobile.
Yeah.
So going through that, to the point where I'm working directly with valve manufacturers to say, hey, these are the failures that we're seeing. These are the problems. This is why we think it may be happening at this temperature or at this flow rate or, at this pressure. That's really kind of where that's the most difficult part of it, is maintaining those relationships where you have a working relationship back and forth. And we're not a very big company by any means. So it's not like we're a Halliburton. It's like, hey, if we work this out, we'll have 100,000 of these things or whatever. It's like, hey, we need to figure one out because I'm not going to implement more into the field until we have a perfect product. Like I want to learn everything now before we start moving forward. That's the biggest issues I've seen so far, is just trying to figure out what products are best for this application.
So where are you guys currently deployed at? Is it still mostly in the College Station area? Are you guys out in
so
Midland,
we home base out of College Station. We're opening a yard up at Pecos. Most of our work has been up there. We were at South Texas for EOG. That's the first place that the unit went, but they had cut their acid back to a point where it no longer justified the use to have a big system like that out there.
Yeah.
So we moved it out to the West Texas area.
Gotcha.
And that's where it's been ever since, jumping pad to pad to pad to pad.
Is there a certain area where it's been more successful than others?
No, I mean, so the system doesn't care. You know, there was some talk at one point in time about running up to the Ohio area for EOG. And
I like Ohio.
Yeah, I mean, I you know, Pennsylvania's pretty.
Yeah.
You know, one of my mentors was up there in Pennsylvania, Mark Marmo at Deep Well. Great dude. I talked to him a lot, but that was just too far for me to really work out the kinks that need to be worked out of it. I mean, it's a new technology. So no matter what technology it is, you're going to have problems, you know? So it's maintained out there in West Texas since February, March-ish. Yeah. And it's literally just bounced pad to pad to pad to pad to pad. And we're rolling.
So what's next, man? What's the next big move for you guys?
So we got a new customer that they're looking at putting on 2 more units. I've kind of found that the larger guys, they take a really long time, which, you know, we talked with the guys at Exxon and they were like, man, you know, it's going to take us every bit of 10 months, 11 months before we can even implement something new like this. And then we'll have to go through our field trials, which is fine. So we've got some more units being built and they'll go out to West Texas as well. It's just keep going, keep trucking.
Yeah, I love it, man. This has been a fun time. I've enjoyed our conversation talking about going down memory lane. Turns out you're related to half the people I grew up with. So no, this has been fun, man. We got to get you back on in the future and hear more about the future development. Sure. But you know, good luck with everything. And where can people go if they want to find out more information? What's the website?
LinkedIn, Texas Integrity Acid Solutions. It's also TexasIntegrityAcidSolutions.com. Got a website there. All the contact information's there.
Cool.
Yeah.
Awesome, man. Dude, thanks for coming.
Yeah, man. Appreciate it.
It's been great. All right, guys, take 2 seconds. Send this to your friends. Reach out to these guys if you want to learn more information. And we'll catch you guys on the next episode.